Okay, how about the half angle identities? Okay, so when it comes to the half angle identities, we'll use the concept of the double angle identities to solve to derive the formula. So let's recall that cosine 2 theta is equal to 1 minus 2 sine squared theta. So if we'll identify for the half angle, let's represent that theta as x over 2. Okay, so let's try to represent it as x over 2. So as you can see here, if we substitute, we'll obtain cosine times the quantity of 2 times x over 2. So let's cancel. That's x is equal to 1 minus 2 sine squared x over 2. Okay, sine squared x over 2. So we have here, so if we simplify that, that is cosine x is equal to 1 minus 2 sine squared x over 2. Okay, so since we are after with the half angle, let's manipulate this. Let's have this negative 2 sine squared x over 2 in our left hand side, and then this cosine x in our right hand side. Okay, so we have here 2 sine squared x over 2 is equal to 1 minus cosine x. And after that, let's divide it both sides by 2. And then we'll obtain this sine squared x over 2 is equal to 1 minus cosine x over 2. So in this case, as you can see, we have the square. So for us to obtain that half angle identity of the sine, let's square root both sides. Okay, so if we square root both sides, we'll obtain this sine x over 2. The half angle of the sine is equal to positive negative square root of 1 minus cosine x over 2. Okay, so therefore this is now our half angle identity for the sine. Now, how about for the cosine? So for the cosine, let's try to recall again the formula for the cosine 2 theta or the double angle for the cosine, which is 2 cosine squared theta minus 1. So it's important for you to recall this, okay, the derived identities. Okay, and then as we substitute, same procedure, let theta be equal to x over 2. So if we substitute that, so we'll have cosine 2 times the quantity of x over 2 is equal to 2 cosine squared x over 2 minus 1. Okay, so again, this one is cancelled. So we'll obtain cosine x is equal to 2 cosine squared x over 2 minus 1. Okay, so same procedure. Let's combine it. Let's add both sides by 1. Okay, and then we'll obtain this. 2 cosine squared x over 2 is equal to 1 plus cosine x. Okay, and then divide both sides by 2. We'll obtain cosine squared x over 2 is equal to 1 plus cosine x over 2. And then since we need to have that cosine half angle identity, let's square root both sides. And we'll obtain this one. Cosine x over 2, the half angle for the cosine, is equal to positive negative square root of 1 plus cosine x over 2. So this is now our identity for the cosine half angle. And then for the tangent, so as we all know, it's the quotient identity for the sine and the cosine. So let's just substitute the identity that we obtained from this two. Okay, so with that, we'll have this positive negative square root of 1 minus cosine x over 2 all over positive negative square root of 1 plus cosine x over 2. So obviously this positive negative is cancelled. So we'll obtain this one. Square root of 1 minus cosine x over the square root of 2. So using the property of radicals, we'll have this, we'll obtain this, and this is cancelled. The square root of 2. If we will use the reciprocal of this, if we use the multiplication here, the square root of 2 is cancelled. Okay, so in this case, we'll have the square root of 1 minus cosine x over the square root of 1 plus cosine x. Or simply, the square root of 1 minus cosine x over 1 plus cosine x. Okay, so this is the identity for the half angle identity for the tangent. Now, another one, we can simplify this actually. If we multiply it by the square root of 1 plus cosine x over 1 plus cosine x. Okay, to remove or let's rationalize this to remove the radical in our denominator. So with this, if we simplify this, we'll obtain 1 minus cosine x times 1 plus cosine x is simply 1 minus cosine squared x. And then 1 plus cosine x times 1 plus cosine x is the square of 1 plus cosine x. And as we all know, 1 minus cosine squared x is just simply sine squared x. Okay, so if we square root this, obviously we'll obtain that sine x over 1 plus cosine x. Okay, so if you want to simplify this using 1 minus cosine x, you'll obtain this one. Tangent x over 2 is equal to 1 minus cosine x over sine x. If you will use 1 minus cosine x here instead of 1 plus cosine x. So either of the two, this is acceptable for you to use in our half angle identity for the tangent. Okay, so we have 1, 2, and this 1, 3. You can use this as our half angle identity. Okay, in simplifying our expressions or even for proving identities. Okay, we can use this. So let's use the half angle identity to find the exact answers for the following. So for instance, we have your sine x is equal to negative 7 over 25. And we have the condition that the angle is between 270 degrees to 360 degrees, which implies to quadrant number 4. Let's find for the cosine x over 2, or the half angle for the cosine. So as we all know, we have here the formula for the cosine. And let's try to identify the cosine x. Since the given here is sine x, let's solve for the cosine x. Okay, so if you will recall, again, you can use the our old method in using the right triangle and then applying the Pythagorean theorem, or just applying the identities that we derived earlier. For instance, we have the cosine x is equal to uh, positive, negative, square root of 1 minus sine squared x. This is one of the identities that we derived earlier. Okay, and we can use this, okay, in order to obtain the cosine x. Okay, so again, you can use the old method in using the right triangle, the Pythagorean theorem, or just simply apply this identity, okay, to obtain the cosine x. Okay, so if we will substitute that, since we are after with the quadrant number 4, so the cosine x here is positive, right? The cosine is positive in quadrant number 4. Okay, so if we substitute that, that is square root of 1 minus the quantity of negative 7 over 25. Then from this, if we simplify this, 1 minus the quantity of negative 7 over 25 squared, the result of that is just simply 24 over 25. Okay, so again, you can use these identities to solve also for the cosine and the sine, and even with the other trig ratios. And okay, so with that, let's try to substitute now in our formula. Okay, so cosine x over 2 is equal to positive negative square root of 1 plus 24 over 25 over 2. Okay, so in simplifying this, we have 7 square root of 2 over 10. Now, we need to decide if we will use the positive or negative value. Now, how? By identifying the angle or the location of the angle in our Cartesian plane. Okay, so with this, if we have the x as our angle, it is between 270 and 360. But if we have the half angle, we need to divide both sides by 2. Okay, we need to divide both sides by 2. Okay, and that is 270 divided by 2 is 135 and 360 divided by 2 is 180, which is this one. Okay, and 135, between 135 and 180, this is quadrant number 2. And as we all know, in quadrant number 2, cosine half angle, or cosine is negative. Okay, cosine is negative in quadrant number 2. So therefore, our answer now here is negative 7 square root of 2 over 10. So this is our answer. Okay, so again, it's important for you to recall the signs when it comes to the trig ratio of sine, cosine, tangent, cosecant, secant, and cotangent uh, in different quadrants. Okay, for you to identify what is the sign. Okay, so let's have another example. Cosine x is equal to negative 15 over 17. And we have the angle between 180 to 270, which is in quadrant number 3. Okay, which is, this is one is in quadrant number 3. So we have here cosine negative 15 over negative 15 over 17, and we need to identify the tangent x over 2. Okay, so actually, our formula, if we will use this square root of 1 minus cosine x over 1 plus cosine x, no need to identify for the value of the sign. All we need to do is to just substitute it. Okay, and then we'll obtain the answer. So tangent x over 2 is equal to 1 minus the quantity of negative 15 over 17 over 1 plus the quantity of negative 15 over 17. Okay, and in simplifying this, we'll obtain 4. However, we need to identify again the sign by looking at the half angle. So we need to divide it again by 2. 180 divided by 2 is 90 and 270 divided by 2 is 135. And as we all know, 90 and to 135 is in quadrant number 2. Okay, in quadrant number 2, the tangent there is negative. Okay, because we have sine over cosine, and cosine there is negative, right? Since the sine there is negative, the cosine there is negative, so negative over positive over negative is negative. So therefore, the tangent here is negative 4 instead of just 4. Okay, so again, it's important for you to master also the sign, okay, of each trig ratio in quadrant number 1, 2, 3, and quadrant number 4. Now, okay, so from this one, let's try to prove, okay, the following identities here. So given that we have the tangent, half angle of the tangent is equal to cosecant theta minus cotangent theta. Okay, so here in this case, let's try to use the formula of the half angle of the tangent. Okay, to have this right hand side. Okay, so let's use the formula for the left hand side. Half angle of square root of 1 minus cosine theta plus over 1 plus cosine theta. Okay, so in this case, let's try to substitute it. So we'll have this as in our left hand side. And let's try to simplify this by multiplying it, the numerator and denominator by 1 minus cosine theta. Both the numerator and the denominator. Actually, this one is the same, almost the same with previous, okay, derivation. Okay, but this time we use 1 minus cosine theta. Okay, so with that, we'll have the square root of 1 minus cosine theta squared in our numerator, and in our denominator, this is the difference of two squares, 1 minus cosine squared theta. Okay, and 1 minus cosine theta squared is just simply 1 minus cosine theta. Okay, if we have the square root And then we have the square here. And then, 1 minus cosine squared theta is just simply sine squared theta. Okay, from the derivation of the Pythagorean theorem. Okay, and the square root of sine squared theta is just simply sine theta. Okay, so we'll have 1 minus cosine theta over the sine theta. And then let's split this. 1 over sine theta is cosecant theta. And cosine over sine is cotangent theta. So therefore, we have here cosecant theta minus cotangent theta, which is the same as the right-hand side. So therefore, we prove the identity. Another example, we have here sine 3x over sine x minus cosine 3x over cosine x is equal to 2. So obviously, we'll manipulate the left-hand side here. Okay, let's manipulate the left-hand side here. So first, let's try to solve or find the LCD first. Okay, let's find the LCD first here. So in finding the LCD, we have here the sine x and the cosine x. So we have sine x cosine x divided by sine x. So that's cosine x times the sine 3x. So sine 3x cosine x minus sine x cosine x divided by cosine x. So that is sine x times the cosine 3x. So cosine 3x sine x. Now, observe the numerator. Sin, cos, cosine. Do you remember any identity here? Okay, actually, this is a sign, okay, difference of the sign identity. Okay, so here we can simplify this one, the numerator, as sine times sine of 3x minus x. Okay, we can simplify this as sine 3x minus x. So if we expand this, use the identity here, difference of the sign, we have this one, sin cos cosine. Okay, so we have here sine 3x minus x, which is sine 2x. Okay, and then let's apply that sine 2x. We know that we have our identity for that. And sine 2x is the same as the 2 sine x cosine x, as we derived it earlier. So here we have sine x in our numerator and same as with the denominator. So as with the cosine x in numerator and denominator. So therefore, the answer here is 2. Okay, so we have in our left hand side as 2 and the right hand side as 2. So therefore, we prove this identity. Okay, so again, it's important for you to recall all those identities that we have, the fundamental 8 identities and also the derived identities coming from those fundamentals. Okay, you need to master that.